All right, so the first section that we're going to take a look at this week is 2.1. And it's on what we call zeros or roots of polynomial functions. Okay. The idea of a zero or a root is basically if you had a formula like this, and I said to you, what number could you plug in for x there so that you get an answer of 0? If you can figure out what number you fill in right here, that's called the 0 of the polynomial. Does anybody see what number you could plug in? 3. Yeah, if you plug in 3 for x, you will get 0 for y. So 3 is called the 0 of the polynomial. So that's what we're going to look at. How do you find zeros? And we're going to do some of it on the calculator. Let's graph this one. Okay, so there's nothing new here in terms of graphing that I haven't shown you before up to this step. So if anybody has questions, let me know. Otherwise, I'm just going to type all that stuff in and assume you know how to get the exponents and all that. Make sure once you do your exponent of 3, press the right arrow because you need to get back out of the exponent, or you're going to type the whole thing in the exponent. So the right arrow gets me back down so I can type the rest of it. That's only when you press the caret button, okay, that you have to press the right arrow when you're done. All right, so we type that in on y1. And what's the window that we normally use called when we're just starting to try to see what it looks like? Yeah?
Z-standard.
Yeah, we're going to just do the standard zoom, which is zoom 6. Yep, standard zoom. Every window in this section, standard zoom will be fine. Okay, so here's our graph. And you should have a graph that looks something like that on your calculator, hopefully. And the question was, how many times does that graph cross the x-axis? Yeah.
3.
Yep, 3 times. Now, if we knew the coordinates of those 3 points, what would the y value be for each one of those coordinates where that curve crosses the x-axis? Yeah,
0.
exactly, it would be 0. Anytime you're looking at a point that's on the x-axis, the y value is always 0. Any question on that? Now, I'm going to type something else in y2. I'm going to leave what I have in y1, but I'm going to type that in y2. In parentheses, x plus 1. Then in parentheses, 2x minus 1. And parentheses, x minus 2. And when I hit graph, I want you to watch what happens to the graph that's already there compared to the one that I'm going to type in right now. So there's y1. What do you notice about y2? It's the exact same graph. So what I have right there is exactly the same as what I have right there. This and that. So I didn't really prove that they're the same. They look the same. But drawing a picture like that never really proves it. They look the same, but that's as far as I'm going to take that for now. Okay, so, but they are the same. Now, let's actually figure out what are the numbers that you could fill in right here so that if you plugged it in and did all the math out, you get an answer of 0. Okay. I'm going to show you how you find it. So we're going to use the calculator. I have 2 things typed in. I don't need them both typed in anymore, but I guess we could just leave it. It's probably simpler to just leave it. I'm going to do second, calc, and I want to find the value that I can plug in for x that gives me 0 for y. Which option up here do you think I'm going to use?
2.
Yeah, we're going to use option 2. We're going to calculate a 0. So press 2. When you press 2, it's going to ask you 3 questions. Let's go all the way to the one on the left. The first thing it says to do is pick a point that is to the left of where it crosses the x-axis. I want to find all 3 of them. I can only do one at a time. So take your cursor and put it somewhere that you know is definitely to the left of where I'm clicking right there. Hit enter. Take your cursor, and the next thing it says to do is to put it to the right of where you know it crosses. Hit enter. If you did those 2 steps on the screen, you should now see 2 dotted vertical red lines. What you've done is you've told the calculator it crosses the x-axis somewhere in between those dotted lines. The last thing that it's going to ask you is a guess. Because it only crosses once between the dotted lines, the guess doesn't matter. Just hit enter, and you get your first answer. -1 is one of the zeros of this equation.
Yeah.
Yeah, we're going to do it again. Okay, so now let's do the one that's in the middle. So we're going to press second, calc. I'm going to go to option 2. And now I need to pick a point that I know is to the left of where it crosses the x-axis. Doesn't matter where, just you definitely have to be to the left.
It's second calc option 2, which is 0.
Yep.
But this is what I get right here.
And you typed in the graph and set the window?
Oh, I did not do that.
Yeah, you got to type in that graph that we had and set the window. Once you put your cursor to the left, hit enter. Okay, and you'll get a vertical line.
I don't get the vertical lines.
It could be that, are you using one of my calculators?
It's the TI-84.
Yeah, it might just do those little, is it just doing these little like triangle things up at the top right there?
Yeah.
Yeah, it's just because it's a little different model. That's okay. Put your cursor somewhere to the right, hit enter again. And now the calculator is going to look in between those dotted lines. And it only crosses once in between those dotted lines. So because it only crosses once, the guess doesn't matter. So just, yep, we'll do it one more time.
Well, like, I'm confused on how you know that it's only one time.
How do I know it's one time?
Yeah.
Well, I'm just looking between here and here. And I can
Oh.
see it only crosses, it's not like, and then I had a dotted line like that, and then it crossed a bunch of times. It's only crossing that one time,
Okay.
right at that one spot.
I think I get it. Can you do it one more time?
Yep, we're going to do it one more time. Okay, so that time I got -1.
I got 1.
Yep, negative 0.5. Yes, thank you. No, it's not negative. It's 0.5. All right, so that's the second one. Now we're going to find the third one. It looks like it's at 2. Okay, just looking at the tick marks and counting. So we're going to do second, calc, option 2. Put your cursor somewhere that's definitely to the left of this point right there. Okay, right there is fine where I have my cursor right. Hit enter. Move my cursor somewhere to the right. Hit enter. And now it's got those 2 lines and it's going to look in between them. And if I did everything right, when I hit guess, it's going to give me that spot right there. So again, the guess doesn't matter. You can put it kind of close if you want to. But it says the 0 is at 2. And that's pretty much what it looked like. Just kind of looking at it by eye. So any questions on how to calculate a zero? The x part?
So when you get the negative 1, 0.5, and 2.
Yep, those are the x parts, negative 1, 0.5, and 2.
Yeah.
I got all those numbers from right there. It gave me a different one each time I did it.
Mine just says yes.
You have to hit enter one more time.
Oh, okay.
Did it say
I
it
see
now?
it, yeah.
Yep.
Now I get it. That makes more sense.
Yep.
So do you have to do that 3 times because it's like just the type of problem that it is? That
The type of calculator that it is.
Well, no. For like.
Oh, why the reason? Yeah. So you had to do it 3 times because it crossed the axis 3 times. Yeah.
Okay.
But you always have to do the left bound, or the left, the right, and the guess, because that's how the calculator is programmed. So
Okay.
whenever you do second calc, and you pretty much choose any of the options that we're going to do all year, you always are going to be asked 3 questions every time.
Okay.
Yeah. So those 3 numbers, negative 1, 0.5, and 2, those numbers are called the roots or the zeros of the equation. If you write them as coordinates, what did we have? Negative a half? No. What was the first one we had? Negative 1?
Yeah.
So if you write it like negative 1 comma 0, that's not a root. That's an x-intercept. Okay, generally, when you're writing an intercept, that's a coordinate on the graph. When you're writing a root or a 0, it's just that number that I circled. I mean, they're similar. Roots and zeros are just numbers. X-intercepts are coordinates. Sometimes there's only 1 root. Sometimes there's 2. Sometimes there's 3. Sometimes there's 20. I mean, we don't normally do 1 with 20. It just depends on the problem. So any question on the difference between an x-intercept and a root, or a 0? Root and 0, same thing.
So when you answer for a 0, you just list them?
Yeah, when you're finding roots and zeros, you just write down the 3 numbers, just like I had right there. If I ask you for an x-intercept, generally I'll say write the coordinate, which is each one of those numbers, comma, and then a 0. Yep.
So when you're writing that, that's only for the x-intercept?
Yeah, when you're writing the full coordinate, that would be for an x-intercept.
Okay.
Yeah. So the easiest equation to find roots for is not the one we just did. It would be a linear equation. And if you wanted to solve this equation for x, it would have 2 steps. What's the opposite of positive b? So if you did a minus b on each side, you could move the b over. And what's the opposite of multiplying by a? Yeah. So if you subtract the b to the other side, whatever it is, and divide by the number in front of x, that is the formula for solving a linear equation. Now, when you draw a line, as long as it's not horizontal, how many times will it cross the x-axis? It can only cross once. I know horizontal might not, but anything besides horizontal only crosses once. So when you're dealing with lines, you only have to find one answer. It's not going to be like the previous problem that had 3. Okay. So the first step, whenever you're trying to solve for the roots of an equation, is to get it equal to 0. I already did that for you in this one. So if you solve that equation for x, what would you get as a fraction?
Uh, 2 over 3, or
Negative 3x.
wouldn't it be? Yeah, 3 over 2.
Well, negative 3.
Negative 3.
Negative 3 over 2. Because you minus the 3 from each side, and then divide by 2. So negative 3 over 2. And that number is the root of that equation. If you plug it back in, you'll get 0.
Wait, could you just put it into the calculator and do the thing we just did though?
I could, yep.
Put it, because I did that and it gave me a difference.
So-
Wait. Give me 1.5, that's the same. Never mind.
oh yeah, negative 1.5, yeah.
Yeah.
The
Could you put it in
calculator
the
will always give you
calculator?
the decimal.
Yeah. Okay, so you
Could
would
you put it
accept
into the
either,
calculator?
even if we did it on the calculator instead?
Yeah, it didn't say how to do this one, so you could solve it either way. Sometimes it might say solve algebraically, and then you'd have to show your steps.
Yeah.
Could you solve it on a calculator? It's just like,
You want me to?
Yes,
Yeah.
please.
So 2x, I'm going to get rid of everything else. So 2x plus 3, I'll do zoom 6, and I'm looking for where it crosses the x-axis. Second, calc 0. Pick a point that I know is to the left. Keep going. Pick a point to the right. And do the guess. And it gives me negative 1.5, which is exactly what we got. I would say when you're solving linear ones, it's probably going to be quicker with algebra because it's only 2 steps. Above linear, then the graph might be faster. So does anyone remember this is linear because the exponent on that is a 1, and when you draw it, it's a straight line. The next step up are ones that look like this. Does anybody remember what shape that is? Parabola, and those come from quadratic equations. So quadratic equations are now a step up, and that's when you have a highest exponent of 2. How many times can a parabola cross the x-axis at most? Twice. Could it only cross once?
Yeah.
Yeah. It could cross once if you had something like this. Touching it is same as crossing it, just touches it one time. How about, is there anything else it could be besides crossing twice or once? Never. Never crosses. So how many zeros can a graph like this have? Well, it could have up to 2, but it could have as few as none. Could be any of those, 0, 1, or 2. And the way that we can quickly figure out how many zeros it has is if you do that calculation. B squared minus 4 times A times C. That's the part that's in the quadratic formula. If that, I think we mentioned this last week, but if the discriminant comes out less than 0, it will never cross the x-axis. If the discriminant comes out b squared minus 4ac, if it comes out exactly 0, it'll cross the x-axis once. If b squared minus 4ac is more than 0, how many times do you think it would cross? Twice. So this calculation, squaring b and subtracting 4ac from it, will quickly tell you how many times it crosses the x-axis. So if I look at that one, b squared is 1 times 4. What's a in this case? 2. And what's c in this case? 4. 4 times 2 is 8. 8 times 4 is 32. What's 1 minus 32?
31.
What is it?
Minus 32.
1 minus 32 is how much?
31. Oh.
Negative.
Negative 31. So if I type that in on the calculator, I guarantee you that that graph never crosses the x-axis because I got negative 31. There's no question. Guaranteed. Never touches the x-axis. So that's a quick chart how you can tell. Now, if it does cross the x-axis and you want to know where, well, then I got to do the whole quadratic formula. That's going to take me a little longer to figure that out. All right. So let's look at this one. So we're solving, it says approximately. Approximately means it's okay to write a decimal. If it said solve exact, then you would have to do quadratic formula. Okay. When you do this on the graphing calculator, it's going to give you a decimal. Decimals are not exact. But I would accept the decimal in this particular problem, just because of the directions. All right, so if we're going to solve it for the roots, the first step is we have to get this equation equal to what? Right now it's equal to 2x squared.
Get x equal to 0.
You got to get it equal to 0. How could you get 0? It doesn't matter which side. How could you get 0 on one side here?
Remove the 2x, or just divide by 2x squared.
So if you divide it by 2x squared on each side, that would leave you with a 1 over here.
Can you just subtract 2x squared?
Yeah, you have to subtract the 2x squared. So you got to minus that from each side. Now you're left with nothing on the left. What would you have on the right if you put it in order from the term with the biggest exponent all the way down to the constant?
2x squared minus 2x minus 1.
Negative 2x.
Sorry, yeah.
Negative 2x squared. Okay, now let's type that in on the calculator. And just doing it in my head real quick, b squared minus 4 times a times c, I can tell that's going to cross the x-axis twice. It's only because the numbers are really small, I can just do it in my head. They're all 1s and 2s. All right, well, let's type it in and let's get the answers. So negative 2x squared minus 2x plus 1. Do zoom 6.
This is looks like
It crosses twice. You got an error. And did you type in,
negative 2x squared minus 2x plus 1.
and you used that for the negative symbol? Make sure you use that for the negative symbol, and then use that for the minus symbol.
Alright.
And why did you zoom 6 again? I forgot.
Just a starting point of where to look. Sets the window negative 10 to 10, so if someone else was using the calculator, I'm starting from a place I know what's going on. That's a negative, it's just the block kind of blacked it out. All right, somebody tell me what I do now to find, say, this point on the left where it crosses.
Second calc.
Second, calc.
2.
Option 2, okay.
And then you move it to the right or left of it.
Move it to the left of it, okay.
And then you move it to the right of it.
Move it to the right of it.
And then you exit.
Oh, don't forget to hit enter after you move it to the left of it too. Move it to the left, hit enter, yep. Move it to the right, hit enter.
Then you just hit enter.
And then we just hit enter one more time, and we get negative 1.366. Test will always tell you how many decimal places to round to.
I'm not getting this. I don't know why.
You're not getting that answer?
No.
You got that picture on the screen?
I have this
I
picture.
just did, yeah.
All right,
It just came up with an error, that's why.
And then I did second calc,
option 2,
option 2, and then I went to the left of it,
hit enter,
and then to the right of it.
right of it, hit enter, and then hit enter one more time.
Does it just stay in the same place and just press enter?
Yeah.
Yeah, mine just saying that there's an error.
So it says x equals 0.366.
0.366, that is correct.
And that question is red.
And that's what you want to write down, 0.366. Okay, remember, when you type it in, you got to get those negatives right. If I move my cursor so you can see it, notice here, this is a negative symbol. That's a subtraction sign. Those are different. Those minuses are not the same. So that's a mistake sometimes people make. Okay, any other questions on getting those two answers?
How did you get the bottom one? The
So we did the second calc 0, and then we just went to the left, to the right, and then the guess, and we got 0.366.
Okay. So
And
it's
for-
just like a different.
What is
So
x?
just get a point.
What is x1?
Okay.
X1, that was the one I got when I did it over on the left the first time. You got to do it twice because it crosses the x-axis twice.
Could you help me with that, please?
Yep.
So I
Second calc,
second calc.
0. Now I got to go over here, pick a point that you know is to the left.
Yeah.
Go over here. Okay, now I can tell I'm to the right of it. Hit enter. And then the guess, and I get negative 1.366.
Could you do it on mine, please?
So second calc, then pick 0. Now somewhere to the left. Yep, that's good. To the right. Too far. No, because you got the other one in there. Can't go that far.
What do you mean too far?
More to the left. Yeah, that's fine, because you only
So-
want to get that one root. And now hit enter.
Okay, so don't go below the x-axis.
Yeah, don't go past the second root.
Why?
Because you only want to get one root at a time. That's all it can do.
Okay.
I've never tried doing 2 at once. Well, I don't think it works. And now just hit enter one more time. And then
Oh,
there's your answer.
all right.
almost.
Yeah. So remember, when you're finding a root, just make sure those dotted lines, you're only getting one x-intercept at a time. And that's it. Those are just 2 answers for that one. That one would not have 3.
But if it had hit a third time on the graph, we'd have to do it for the third.
Then you
time.
do it for the third one. Yep. Let's see. That was nothing. All right, let's try one more of those. Let's try this one. Okay, the directions here are solve, and we're going to do it approximately. So put in x, well, actually, before we put it in, what do we have to make sure it's equal to?
0, so you get to subtract 1.
Yeah.
So x cubed plus 2x minus 1.
There you go.
Yep. So that's what you want to do first. Get it equal to 0. Now type it in. X cubed plus 2x minus 1. Again, I'm going to do zoom 6. I don't think I changed my window at all, but just in case. And it's a cubic, so we know it could cross up to 3 times. But how many times did this one cross?
2. Oh, wait.
1.
Cross what?
The x-axis.
Oh, okay.
1.
Yeah, it just crossed once. And that's fine. Sometimes that happens. Looks like it's about 0.5. But we want to find where it is exactly. So how do I find where it crosses?
Second calc 0.
Second calc,
To the left of it.
go to the left of it, go to the right of it,
And
and
0.45.
Three.
yeah. So yeah, we could just write 0.453. Because again, they said approximate, so a decimal is okay. Okay, so 0.45. Any questions on how we got 0.45?
Why don't you say x1? Just because it's just implied.
When it's only one answer, I generally just put x equals.
What's with the wavy equal sign?
Yeah, well, it's with the wavy equal sign.
It's approximately.
Approximately. It is not exactly 0.453. That's a
If I
round.
wrote 0.45339765, then I can just write the regular equal sign.
No,
Then why don't I write what? Like, why is it approximate?
The problem says.
because it's a decimal. It's not an exact answer.
But isn't a decimal an exact answer? Like,
No.
what is an exact answer then?
An exact answer might have like a square root in it when you do quadratic formula. When we're doing a cubic, we don't have a way, and we won't be learning a way to do an exact answer to something like that in this class. But yeah, an exact answer would be like if you had a quadratic and you did quadratic formula, and you wrote your final answer like this. Because that's what it looks like when you do quadratic formula. That's an exact answer. Once you take the square root of 5 and round it off to 2 point whatever you want to round it to, now it's approximate. Does that make sense?
Yeah.
So this is an example of a cubic, because the highest exponent is a 3. Cubics can have different looks to them. The one we just did, I think it looked kind of like this one. It kind of started to curve a little bit, but it never really curved, and it just kept going. The first one I gave you guys today looked more like one of these. It actually curved and it made the turn. Okay, but that's generally what cubics look like. Sometimes the turn is bigger, like that. Sometimes it's just a little bend in it, kind of like the one we just did. That one. Page 80 shows those pictures in your book, but that's pretty much what you're looking at right there. So third degree polynomials, those do have special names. Those are cubic. Second degree polynomials are called, what's the name for a second degree?
No idea.
Yeah?
Quadratic.
Yep, quadratic. So second degree is quadratic. Third degree is cubic. How about first degree? Linear. Those are the most common names. Generally, when we get above third degree, they just say it's a polynomial degree 5, degree 10, degree 20. I don't know of any special names. I don't think I'm going to do that one. No, we'll skip that. It was just finding more roots. So is there any question on how to do the second calc 0? I think we did a lot of them. So we got one more question we're going to knock that over here. Does everybody have the third degree polynomials? So in the last section, every window Zoom 6 was fine. Remember, Zoom 6 is negative 10 to 10 on the x, negative 10 to 10 on the y. In this section, we're going to have to adjust our window to make it work. So remember last week, I put up a list of strategies that sometimes we use to solve problems. And making an equation and drawing a graph are two strategies that we use a lot. Sometimes we use both together. Like you might make an equation, you don't know how to solve it, so you put it on the calculator and you do second calc 0 and you get the answers. So sometimes it's a combination of the two. This problem we're going to do, it's going to be first make an equation, and we're going to use the calculator. I don't think you really need it to solve it because it's going to be a linear problem. But we are going to do it on the calculator. Okay, so here's our last question. So Bill has $20,000 to invest, and he's going to invest that money into two different things. Each one of the things that he invests in is going to pay him interest. So the interest is money that he's going to make for taking his money, and maybe it's like the stock market or something, something. This isn't the stock market because that's more complicated. But these two investments that Bill is going to put his money into are going to pay what's called simple interest. It's not actually the way the bank would calculate interest. The bank uses what's called compound interest, but the formula is a little more complicated. So we're going to stick with what's called simple interest. And the formula that you'll need in this problem is I equals PRT. So it's 4 letters there. Anyone have a guess what the I stands for? Interest. That's how much interest Bill is going to make. So that's money that this investment pays him, just because he took money and gave it to this company to invest. P, you probably might not know that one. That's the principal. The principal is how much money you invest. So let's say today, after school, you go to the bank, you open a savings account, you put $500 in it. 500 would be your principal. It's what you put into the account. R is the rate. The rate you can get by looking at the percent in the problem, but you have to be careful because you always need your rate to be a decimal. So like if you had 12%, anybody tell me what that would be as a decimal? .12, yeah. So just like, if you wanted to quickly calculate the price of something you're going to pay at the store, if it's, say, $350, you still have to pay sales tax on it. So if you take 350 and the sales tax, what's the sales tax here in Massachusetts? 6.25%. Yeah, so it's 6.25%. So 6.25 is 0.0625. That's how much sales tax you have to pay on something that costs $350. So now you need to add the item price plus the sales tax, and now you're paying like $371.88. All right, so to change a percent to a decimal, all you have to do is move your decimal 2 places to the left. And T, that's the time. It's the amount of time you're going to leave your money in the bank or whatever the investment is. Okay, so what do they want us to do with that formula? Find an algebraic representation for the interest that Bill is going to earn in 1 year. So the time is 1. Because the time is 1, you're going to multiply by 1. Does that do anything? Well, Logan? Yeah, it's not going to do anything. So in this case, you really don't even need T. But sometimes it might not be 1. Okay, how many different investments does Bill have to pick from in this problem? Yeah?
There's 2.
He has 2. So let's say that Bill invests X dollars at 6.75%. I don't know how much he's going to put in that investment. let's say he takes X amount of dollars and puts it in the 6 3/4 investment. Let's figure out how much interest he would make. And again, there'll be a variable in the formula because the amount of money he's putting in is a variable. We don't know it. But let's see how much interest he would make. Okay. So first thing we start with is the principal. How much money is Bill putting in this investment? How about Brett? How much money is being invested at 6 3/4%?
X amount.
Yeah. So he's investing X dollars at 6 3/4%. That is your principal. Okay. What's the rate of this investment? But just be careful. It has to be a decimal. So what's our rate going to be? It's 6.75%. But what is that as a decimal? Yeah. 0.6 is 67.5%. Yeah? 0.0675. When you take your decimal, move it 2 places to the left. And what's the time for this investment? Just a year, so we don't even need that. Okay, let's multiply that together and write it how we normally would. Usually we put the number in front of the letter. And that represents the amount of interest that Bill is going to make in this account, 0.0675x. Now, is that the only account that he has, or does he also have another one? Yeah, he has another one. So we're going to figure out the interest in that account. Now, how much money did Bill have to invest at the beginning? $20,000. How much of that money has he already put in the first account? What's the principal of the first account? Yeah? He already spent X dollars and put it in the first account. So what does he have left for the second account? Because everything that he didn't put in the first account, it's going in the second one. He's going to use all 20,000. Yep.
Wow.
No, not why. It's got to be something with 20,000 in it. Yep. Right, 20,000 is what he had to start with, minus what he already put in the other account. So if you put 1,000 in that account, that leaves him with 19,000 here. Okay, but that's his principal. Okay, what's the rate in this account? What's 8.6% as a decimal? Yeah?
0.08.
Yep. And how many years is he leaving his money in the investment?
1.
1, it says it up there. Find the interest earned in 1 year. So the times 1 doesn't do anything, but I do need to take that and distribute it out to simplify it. Just because I did this earlier, I remember 0.086 times 20,000 was 1720. And 0.086 times negative x, well, it's just negative 0.086x. So distribute that out, that's what you get. Normally I would need a calculator, I just remember the answer. So Bill's going to make some money in the first investment and some money in the second investment.
Go down 1 second.
How would we find the total money that he makes? He made some money here. He made some money, made some interest here. How do we get the total? Yep.
So you add the 0.0675x to the equation from the second one.
Yeah. Just add box 1 and box 2 together, and that's the total. Well, 1720, there's nothing to combine it with from box 1. So 1720 stays right where it is. But I can add 0.0675 plus negative 0.086. So that's negative 0.0185x. What was it? Negative 0.0185. Now, if you give me an amount of money that he invests
20,000.
in the 6.75% account, I can fill it into that formula, and I can tell you how much interest he made. Any question on the formula? And the last thing, we're going to type that in on the calculator, and we're going to get an answer. So let me keep that up, because we need that. So now they're telling us that Bill earned that much money in his investments. He earned a total of $1,509.10. Where would that get plugged in? Box 1, box 2, or the total? Yeah?
Box 2.
So that, it says Bill earned a total of $1,509.10.
Oh, box 2.
So yeah, that's going to get plugged into the total. That's his total money he earned. Doesn't say that's the amount of money he earned just at one of them. That's the total. Where would it get plugged in for the total?
I.
For what?
I.
Yeah, it get plugged in from I. So you'd have 1,509.1 on the left. You have this on the right. And what are we solving for there?
X.
Yeah. But I want to use the graphing calculator. Not that I couldn't do it algebraically. I just want to do it on the calculator. So we're going to do this one just like one we did last week. You're going to put the left side, $1,509.10. Put that in Y1. You're going to take the right side, and you're going to type that in Y2. And what do you think? Oops, I just copied this wrong. Small change, but important change. Negative 0.0185x. So I've got the left side in Y1, the right side in Y2. When I hit graph, what do you think I'm going to look for?
Any line at all.
Well, I'm going to get two lines on the screen, and I'm going to look for where the line in Y1 equals the line in Y2. What does that mean? Yeah, where they cross. So X is the amount of money. Is there a maximum amount of money Bill has? How much is it? Then we can't invest more than $20,000. Is there a minimum amount of money he could invest? Well, between the two investments, he could choose, in terms of how much money he chooses to put in the first one. He could put it all in the first one, or he could put
Zero.
You could put none in the first one and say, I'm going to put it all in the second one. So it's somewhere between 0 and 20,000. Bill's making money, he's making interest. So what kind of number wouldn't make sense for interest to be?
0.
Yeah, we would never have negatives. He's not going to lose money. Right? He's not losing money, so we wouldn't have negatives. And look at this line right here. What's the y-intercept of that line? Yep, it's 1,720. So you need to set your y max at least, I'd probably do a little higher than that. I'd do like 1,750. And it has a negative slope. So it's going to cross the y-axis way up at 1,700 and it's going to come down. If you don't set it to 1,700, it won't be high enough. So there's our line for 1,509. There's the line with the y-intercept and the negative slope. And what do we have to find?
Crossing point?
Yeah, find where they cross. So second calc intersect. And we did intersect last week. It asked you 3 questions, but you can just hit enter 3 times because do they cross more than once? All right. So that piece of information gives me my answer. What letter did we just solve for? Yep, we solve for x. And what does it say up above that x is? Yeah.
Principal.
The principal in which account? Because there's 2. Assume X dollars is invested 6.75. So that's the, we just solved for X. So that's the amount of money in the account. That's 6.75. So how much money does that leave for the account that had 8.6%?
8,600.
Yep, because that's what's left over. 8,600. So you just have to remember what that number represents. So sometimes I have to go back and just read the problem and see what it is. All right, so that's 2.1, and then the first part, just that one question in 2.2. Let me double check. I'm just going to change a couple of them, not much, but. Let's make that one. 3, 9 to 11. Yeah, that's it. So we will take a look at that tomorrow.